Hello guys, welcome to Carrying Math. My name is Godwin. In this tutorial section, we will look at the design of a Yagi-Uda antenna at a resonating frequency of 2.5 GHz using HFSS. First, we will study the theory and introduction of the antenna. This is how the Yagi antenna looks like. We have the reflector that is at position 1, the driven element that is a dipole. This can be seen as a dipole with signal being fed at the middle. The rest are all directors. This antenna works in a way that this dipole will emit signals in all directions, but with the help of this reflector, the signals are bounced. It's like reflection of light. They are bounced when they strike the reflector. They are bounced back into this direction. So it is no longer omnidirectional antenna, but a directional antenna. By theory, the reflector should be 5% greater than the dipole, and the difference in height between these reflectors are usually negligible, like they are very minimal. They don't usually differ, so the difference in their distance is small. So I have with me their dimensions. So I would minimize this, select this one too.
Audio Jungle.
So this is said the length of the driven element of the Yagi is 0.458 lambda to 0.5 lambda. So as we saw in the dipole antenna, we can use any value between 0.5 lambda or 0.458 lambda to 0.5 lambda, and the length of the reflector is 0.55 lambda to 0.58 lambda. Length of the director, that is the first director, is 0.45 lambda. The second director is 0.4 lambda. So the difference between the first director and the second director is 0.05 lambda. So with this design, I will design the Yagi with one reflector, one driven element, and one director. Let's dive in. I will rename my project as usual. K for KindMac _ Yagi-Uda. After renaming my project, I would insert HFSS. After inserting HFSS, I will compute for my most important parameter, that is lambda. So I can do that when I have speed of light, capital C, unit type to be speed. After my speed, I need frequency, capital F. Frequency, unit type frequency, we are designing at 2.5 GHz. When I'm done, I would compute lambda.
Audio Jungle.
That is capital C divided by F, giving me 0.12 meters. So my lambda is 120 millimeters. With our design, we would need a calculator. Over here, together with our image containing the dimensions. So we will first of all start with our reflector, and we know that the length of the reflector is 0.55 to 0.58, so I would choose 0.56. 0.56 times 120, so I'm having 67.2 with the radius of the poles or the elements. I would choose a gap of 0.125 millimeters, meaning that my radius will be half of my gap. Giving me 0.065. Alright, so I would draw my, let me change the plane to IZ. I will draw my cylinder. Change the name to reflector. Assign PEC or any material, any conducting material will be fine. Copper can be used for this same project, but I'll use PEC, and I would adjust it. My radius should be 0.065 with a height of 67 point, what is my calculator, with a height of 67.2, but I just wanted to divide my coordinate into two, so I would check this lies directly on the S, so I'll choose 0, 0 for this side, but for X we choose minus 67.2 divided by 2. You get something like this, lying directly at the middle. This is it. Good. And we will calculate the distance between this reflector and the dipole. We will go to our image again. Says the spacing between reflector and dipole should be 0.35 lambda. So first of all, calculate 0.35 times 120, giving me 42. So the spacing between my reflector and dipole is 42 millimeters, while my length of the driven element will be 0.5 lambda. So 0.5 lambda is 60 millimeters with a spacing of 0 with a gap of 0.125. so this is what I will do. I would divide my 60 into 2. First of all, I have to subtract my gap from my total length, that is 60 minus 0.125. I get 59.875. so this is the distance that I get after subtracting my length of the gap. So if I want to get the length of one dipole leg, I will just divide my 59.875 divided by 2, which I get 29.94. So I would draw name it dipole, assign material PEC, assigning the material. The spacing is along the y-axis, so for y should be 42 mm. That is the spacing that we calculated for the distance between the reflector and the dipole. Same radius, that is 0.065 with a height of 29.94. But here is one thing, we would introduce a gap, so we want this structure to be elevated an amount of half the gap along the s-axis. So this wouldn't touch the y line over here. I would just elevate it 0.125 divided by 2 from the x-axis. Maintain this side to be 0. This is it. So I would pan and zoom. Rotate to see if it is elevated. It is elevated, but it cannot be seen very well. I'll just have to zoom. Okay, my coordinate system vanishes when I zoom, but it is elevated. So what we will do is that we would use the duplicate method and do the same thing at the other side. So we'll choose around as this 180 degrees. So it is present, but I need to zoom before this. It can be seen that the gap is present. Yes, that is the gap. So everything is okay. I just have to insert my port. So with the port insertion, we just choose this plane, makes it easy for me. I'll zoom. Insert the port. But I need to change the plane. I mean XY. This is okay. After assigning my port, we'll change the name to port property window and assign a citation to it, Lambda port. It is defined with no error, so I can proceed. I'm done with the dipole, so I will move on to the director. That is, I already informed you guys that we are only doing one dipole, one reflector, and one director. So with the first director should be 0.45 lambda, and the spacing between dipole to the director is 0.125 lambda. So I will first calculate the spacing. 0.125 by 120, that is 15 millimeters, and the length of the director should be 0.45 by 120. Sorry, 0.45 by 120, get 54. Okay, that's great. So my director should be 54 mm in length with a spacing of 15 from the dipole. So I would change my plane. I would zoom out. So I would draw another cylinder over here. I can name it director. Change to PEC. After changing to PEC, I will adjust it with radius 0.065, length of 54 mm, but I want this 54 to divide the coordinate into 2, so we'll choose minus 54 divided by 2. The 0 over here should be fine, with a spacing. So our spacing was 15 mm. This will be okay. I need to check something. Alright, so with their radius, I omitted a value, that is 2 should be here. I don't believe, I think there is something wrong. This is the director. It should be after the dipole. Let me cross check something. Okay, this is the spacing from only the dipole to the director. So we should add up to the previous spacing we had. So this should be over here. So we should add our 15 to what we had for this one. So I will check the spacing between dipole, reflector, and dipole. So I will check spacing between the spacing for reflector also. Okay, 0. I will check spacing for the dipole. We had a space of 42, so we would do 42 plus calculator. So we will do 42 plus 15. So the spacing should be 57 instead of alright. So everything is okay now. This is a reflector, very thin. There is a reflector, a dipole, and the director is over there. So I would draw a box to cover all
Audio Jungle.
my shapes. So I will name the box box. Vacuum is okay, but I would reduce the transparency to see how my work is aligned inside. So for the Y direction, my distance will have to be a bit huge. 142 will be okay. X direction, 100 will be okay. With Z 50, okay, let me choose to be 60. I always do, I want them to align, so minus 100 divided by 2 minus 142 divided by 2, then we'll have 60, minus 60 divided by 2. Check how they are aligned inside. So my work is
Audio Jungle.
aligned perfectly inside, but I would want to shift it a little bit to the right. And select them. So they are aligned, and I would like to shift a little bit to the right. So that is the Y direction. I'll divide by 3 instead of 2. See how they are. Alright. I think it is okay now. Would assign a boundary to the box. That is radiation.
Audio Jungle.
So we'll check my design, see if everything is alright. Citation tool is defined. So I will check I'm left with analysis setup. .5 GHz maximum sweeps, then will be okay. Interpolating too fast. Start at 2, end at 3.5. with points of, let's say, let me choose step instead of count. Zero point 0.02 will be okay. And down this okay. That's okay.
Audio Jungle.
Validate, everything is alright, so I can analyze.